Let's talk about the second derivative test for local extreme values. This is a different statement than the second derivative test for concavity. The second derivative test for concavity just tells me whether I have that concave up shape or that concave down shape in my graph. The second derivative test for local extreme values actually helps me determine if I see a max or a min. Go on and read through what I have written on the board here and then pause the video and try to fill in these blanks, just thinking about what we know about the first derivative and second derivative. Try not to use your book or your notes and just guess. Do your best. It's okay to challenge your intuition. Go on and pause the video. Okay, so I'm hoping you tried to fill in the blanks on your own. What I'm going to do now is talk about what all this means and give you another chance to revise what you've written down. In this first statement, I'm told f prime of c equals 0. That means c is a critical point, which means I might have a local min or a local max at that value. I'm told here that the second derivative is less than 0, which means at that critical point I have a concave down shape. In the second part, I see that f prime of c is equal to 0, and the second derivative is positive, which tells me that at this critical point I would have a concave up shape. See if that helps you figure out what should go in those blanks. Okay, so the big reveal. If I have a critical point, f prime of c equals 0, that tells me I have a slope of 0. Put that together with a concave down shape, and that means at that critical point I must be at the top of a hill, which means there is a local maximum at that value c. If I have that critical point and a horizontal tangent line put together with the fact that my graph is concave upwards, it means that critical value is happening at the bottom of a valley, which tells me there's a minimum. All right, and here I have a statement that both things are equal to 0, the first derivative and the second derivative, and the big statement here is that the test fails. And what that really means is there may be a max, there may be a min, and we don't know. Which is kind of sad when we don't know. All right, the second derivative test is a very nice way of checking for maxes and mins when the second derivative is easy to calculate. When we get to section 4.6, this is a nice trick in application sometimes, just by calculating a second derivative to know if we're finding a maximum or a minimum at a particular critical point.